Okay, right now we're going to take a look at the derivatives of our hyperbolic trig functions. Let's just start by taking the derivative of cosh of x. Now, eventually, this is going to be a formula that I know. But if I don't know it yet, I want to write cosh in terms of functions whose derivatives I do know. So I can say this is just taking the derivative of e to the x plus e to the negative x over 2. You might be tempted to use quotient rule here because this is a quotient, and you could, it wouldn't be wrong, but it's much more efficient if we use the constant multiple rule, because this is really just 1/2 of e to the x plus e to the negative x. So this denominator is just constant, so I'm going to factor it out as a fractional constant, and now I can say the derivative is just 1/2 of the derivative of e to the x is e to the x, plus the derivative of e to the negative x, I'm going to need to use chain rule for. So I'm going to get e to the negative x multiplied by the derivative of negative x, which is just -1. And now if I simplify this, I'm going to write that as e to the x minus e to the negative x. And I'm going to go back to writing that multiplication by 1/2 as division by 2. This should look pretty familiar, because that, in fact, is just our formula for sinh. So we've got that the derivative of cosh is sinh. Now, we've got 5 more hyperbolic trig functions. I'm going to have you pause the video and try and work out the derivatives of those. Then you can turn the video back on and check your work. Let me just give you a strategy. I'm going to suggest that when you find the derivative of sinh of x, you do the same thing that we did for cosh. You write it in terms of the exponential functions. So you're going to say this is just the derivative of e to the x minus e to the negative x over 2. And once again, you can factor out that 2 as a constant of 1/2 that you're multiplying by. These are the only 2 that you have to write in terms of the exponential functions in order to calculate the derivatives, because all of the other hyperbolic trig functions we can build out of sinh and cosh. So when it comes time to take the derivative of tanh of x, I'm going to suggest that you write that as sinh of x over cosh of x, because by this point you'll know the derivative of sinh and we know the derivative of cosh, and you can just use quotient rule. And you can do that for the remaining 3 hyperbolic trig functions as well. So the derivative of sech of x is the derivative of 1 over cosh of x. And you can decide whether you want to use quotient rule or simply rewrite that as cosh to the -1 and use chain rule. That's cosh to the -1 power, not cosh inverse, because I put those parentheses right there. And you can do something similar with sech and cotanh. So go ahead and stop the video, work out the derivatives for the remaining 5 hyperbolic trig functions. When you're done, turn the video back on and you can check your answers. Okay, so here we've got our results. We can see for sinh, we rewrote it in terms of the exponential function. Again, factored out that constant. So we get that same constant times the derivative of e to the x is e to the x, minus the derivative of e to the negative x is the opposite of e to the negative x, again by chain rule. These 2 negatives cancel, so we get e to the x plus e to the negative x over 2, which happens to be cosh of x. Now, for the derivative of tanh, I wrote that as sinh over cosh, and so now we're just using the quotient rule. So we get the bottom function cosh times the derivative of the top, minus the top function times the derivative of the bottom over the bottom function squared. Since the derivative of sinh is cosh, this first piece becomes cosh times cosh, which is cosh squared. Since the derivative of cosh is sinh, this term that we're subtracting becomes sinh times sinh, or sinh squared. But now on top, we've got cosh squared minus sinh squared, which we know is 1 by our our identity. Okay. So we get 1 over cosh squared, which is just sech squared. Now, when we take the derivative of sech, I rewrote that as 1 over cosh, which is cosh of x to the negative 1. Quick note, before we paused the video, I had forgotten to write the d by dx here. I noticed that while you had the video turned off, so I have fixed that now. There should be a d by dx in front of this term. I chose to use it this way, so I just used chain rule. So I said, okay, I'm going to get negative 1 copies of cosh x to the negative 2 multiplied by the derivative of the inside part, which is cosh. So we get negative 1 over cosh squared times sinh, and then I just sort of regrouped the factors. Negative 1 over 1 factor of cosh. The second factor of cosh I paired with the sinh, and that way we get negative 1 over cosh is negative sech, times sinh over cosh is tanh. Cotanh and cosech are very, very similar to tanh and sech, so I'm not going to talk through. I've got all the work shown here. I'll just leave that for you to see. But you might notice that the pattern for these derivatives is very similar to the pattern that we see with regular trig. With regular trig, the derivative of sine is cosine. The derivative of cosine is negative sine. The only differences in these formulas are with hyperbolic trigs, we've got all the h's, we're getting the hyperbolic trig functions, and where the negative sign is in the formula. So with regular trig, if there's a co in the name of the function, cosine, cotangent, cosecant, there's a negative sign in the formula. With hyperbolic trig, the 3 fundamental ones, sinh, cosh, and tanh, no negative sign in the formula for the derivative, but the 3 reciprocals, sech, cosech, and cotanh, have a negative sign in their formulas. Other than that, it's pretty similar pattern to what we already know from regular trig, and those are our derivatives.